Hello everyone, here are the answers to the rest of yesterday's worksheet. So I do have 1 through 4 included on here again. Let's take a look at 5 and 6. Five we did as an in-class example yesterday, so let's just jump straight to 6. So again, A, the most number of peaks or valleys, so the maximum number of relative extrema is always the degree minus 1. So number 6, the degree is 3. So 3 minus 1 will give us this answer of 2. Now remember, for B, it's actually just part B here for the relative max and min. This is actually part C right here. So we want to state the relative max is y equals negative 2.742 when x is equal to 0.263, and the relative min is going to be stated this way as well. So make sure that they look like those statements. Now for number 7, you could have stated this as 1 for the relative min. You could have said the relative min is y equals 1 when x equals 0 and x equals 2. If not, you could have just written out 2 separate statements. Now for 8 and 9, we had to state the zeros, so we always want to list our zeros in the set brackets. Number 8 only had 1 real 0. And again, pay attention to the answers to part B, how they're worded. Now for C, you could have said the y-intercept, the coordinates here could have been 0, 3, or just saying the y-intercept is 3. Either one is acceptable. All right, for number 10, single zeros occurred at R, M, and L. Double zeros, there weren't any for number 10. C, the y-intercept was at J. D, all relative minima, so all the valleys, that just happened at K. E, all the relative max, were just at Q, we only had 1. And then the x-intercepts are R, M, and L. X-intercepts will match all the real zeros here, single zeros as well. For number 11, single zeros were just K, P, and R. Double zeros were M. Y-intercept was Q. All relative minima, that was at M and N. Max values, relative max, happened at L and J. And all the x-intercepts, K, M, P, and R. Now for 12 and 13, just wanted you guys to use the tool icon in Desmos just to try to fit a nice x-min, x-max, y-min, y-max to fit the graph in the window viewing area as best as possible. So I didn't want you to just zoom in or zoom out. I want you to practice using that tool icon off to in the upper right corner. So let me know if you have any questions over this homework assignment. All right, today we're moving on, and the worksheet I posted as a PDF. I'm just going to do some problems off of that. So our goal today is to be able to sketch the graph of a polynomial function, given enough of information, then write a possible equation of a polynomial function given the graph or description. So there's going to be 2 ways to write a polynomial function. And pause the video at any time as you see fit. So these 2 ways are going to be factored form and expanded form. Now because we're writing a polynomial function, we either want a y equals or f of x equals. In factored form, we just see the individual factors. So we can see a monomial factor, and then we might see some binomial factors. Now expanded form means to multiply the factored form together. So as we go to do that, so this just means multiply the factors. So I would always suggest multiplying the binomials together first. So let's do that. So here we're going to get x squared. On the outside we'll get a plus 1x. Inside we'll get a minus 6x. And then last we'll get a minus 6. So this will give us x times x squared minus 5x minus 6. And then we distribute the x. So we'll get an x cubed minus 5x squared minus 6x. So this would be our polynomial function, but keep the f of x out in front. So what's going to help us to write these polynomial functions is understanding this important theorem. It's called a factor theorem. So if we have this factor here, x minus c, so if this quantity x minus c is a factor of a polynomial we'll call p of x, then c is a 0 of p of x, because we would just take x minus c, set it equal to 0, and solve. So x equals c is a 0 of p of x. And we can use this in reverse. If I were to say 5 is a 0 of p of x, then the factor x minus 5, or the quantity x minus 5, is a factor of p of x. Now, to get that monomial x, the only way to do that is if 0 is a 0. So I'll just say if 0 is an x-intercept of p of x, then x, because technically it's x minus 0, which is just x. So we'll say x minus 0, which is just x, is a factor of p of x. All right, so off of the new worksheet I posted today, we're going to take a look at number 13. Now here are the directions. It says, A, given the graph of a polynomial function, write a possible equation in factored form, and then you can check with your graphing calculator or Desmos. But if the problem has a part B, then we want to also expand the factored form. So this is, I know it's a little bit tough to see, but this is the graph from number 13. It has a B next to it. So this is where we need to determine, do we have single zeros, do we have double zeros? So on the graph, I'm going to go ahead and put a point at every real zero, or x-intercept. Now if you notice, the graph crosses through all of those, so we have 3 single zeros. And they are at -3, +2, and +4. So now to answer part A, our equation f of x, so if we have a 0 of -3, inside the factor here we're going to have x minus a -3, or we just do the opposite. We get a factor of x plus 3. If we have a 0 at +2, then we're going to have a factor of x minus 2. And if we have a 0 of +4, then we're going to have a factor of x minus 4. So this is factored form for part A. Part B, we just want to multiply all this together. So again, I'm going to go with the last 2 binomials. I want to multiply those together first. So we have x squared. Outside will give me a minus 4x. Inside will give me a minus 2x, and then we'll get a plus 8. I'll combine the like terms here, so we get x plus 3 times the quantity x squared minus 6x plus 8. And then very carefully, I want to distribute the x first. So this will give us x cubed minus 6x squared plus 8x. And then I'll distribute the 3. So this will give us plus 3x squared minus 18x plus 24. And then we combine like terms. So this gives us x cubed. If I combine my x squared terms together, we're going to get a minus 3x squared. 8x minus 18x is a minus 10x plus 24. So this is what you want to do to check. You want to graph this. So in Desmos, you're going to type this in. Also in Desmos, you're going to type in the factored form. They should match if we expanded everything correctly. And it should look like the graph that we gave you in number 13. Now what might be a little bit different is how far up or how far down it reaches, but it should definitely be going up first through -3. Some sort of a max occurs up here, then it turns and goes down through 2, turns again and goes up through 4. Okay, let's take a look at 21. So let's go ahead and put points on the graph at all of the x-intercepts. Let's identify the single zeros here. So we have a single zero at -2, at 0, and at 3. And we do have a double zero at -4. Now this one doesn't have a b, so we don't have to expand it. We just want factored form only. So we start by writing f of x is going to equal. Now I always like to start, if there is an x-intercept of 0, I always want to start with that first because that means we just have a factor of x. Then I'm going to start with the x minus the -2, so we're going to have an x plus 2 and x minus 3. Now for this double 0, this will turn into an x plus 4 because it's double. We're going to put an exponent there. And you can see why we don't want to expand this. It's going to be way too large. So we just leave it like this. All right, so in those two examples, we were given a graph. Now we're going to do the reverse. And again, these are just possible graphs. They could look different in certain areas, but they should still have the same common characteristics, the main characteristics here. So let's say we just have single zeros of x equals -4, x equals -1, and x equals 3. We're going to sketch a possible graph. So I'm actually going to do this twice just to show you the two possibilities. So that means over here at -4, I have an x-intercept. At -1, we have an x-intercept. And then at 3, we have an x-intercept. So my graph has to go through, now these are all single zeros, so my graph has to go through the x-axis through these. So what can happen is I can go up through the -4, at some point turn, come back down through the -1, turn, and go back up through the 3. So there's one possibility. What's another? Just sort of the direction. I did not have to necessarily go up through the -4. I could have come down through the -4, turned and went back up through the -1, turned and went back down through the 3. So these are the possibilities here. So it could look like this. Again, what's going to vary is how far up we had to go to turn, how far down. That we don't know yet, but we just wanted to get a possible sketch of the direction, the turns, and the x-intercepts. So a possible equation, which is what we were just doing, we could say f of x is going to equal, if we have a 0 of x equals -4, what would that look like in parentheses? Hopefully you're thinking x plus 4. Then we would have an x plus 1 for the -1, and then an x minus 3. Now you could type this into your calculator on Desmos. Remember, it could be y equals or f of x equals, but we have to see this part. If you just have the factors, that's not an equation. So you could check on your calculator, pause the video to do that. But we also want to expand this. So again, if you want to pause the video, practice expanding this, and then see what you come up with. My advice is just to multiply the last two together first. That leaves the binomial out in front. Just a little bit easier. So if you're ready, just resume playing. If not, pause the video some more. But here we're going to get x squared first. On the outside, we'll get a minus 3x, inside plus a 1x, and then a minus 3. Then we have x plus 4. Combining our like terms, we'll get an x squared. We'll get a minus 2x in the middle, minus 3. And then again, as I did earlier, we'll just go ahead and multiply everything by x first. So we're going to get an x cubed minus 2x squared minus 3x. Then we multiply everything by a positive 4. So then we'll get plus 4x squared minus 8x minus 12. Combine our like terms, so we just have the x cubed. We have a minus 2x squared plus 4x squared, so we'll get a plus 2x squared. Negative 3x minus 8x is minus 11x, and then a minus 12. So you could graph this, f of x is equal to this as well. And it should match what you're graphing here for part B. All right, so off of today's new worksheet, aside from the problems that we just went over, continue working on this from 14 to 27. So I know we did 13, we did 21 and 22, so you do not have to do 21 and 22. And as always, guys, let me know if you have any questions.